Welcome, Algebra 1, 2, connecting y equals mx plus b with the stacking towers activity that we did. And if you remember, we had this pattern of blocks, and each figure grew a little bit. And if we look at this, we had to find the next few and draw them and really just find the height. And you guys noticed pretty quickly that these were going up by 2 each time. And you were able to find that, let's see, if the fourth one was 4, 5, 6, 7, 8, 9 high, then the fifth one would be, yes, 11 high, and then, yes, 13 high, and then, yes, 15 high. And then the next thing that you did was you had to find the height of tower number 0. And this was something that turned out to be pretty important once we found it. That height was simply 1. We've been going up 2 each time, going this direction, so if we went backwards, it seems only natural to go down 2 to get to that tower. Well, because this is a constant rate of increase, this is what we call a linear pattern. It will give us a line because it's changing by the same amount each time. And if you notice, the tops of these towers seem to go in a straight line. We found that the rate of change, we're going to call it m, that we could put that in a certain place in this magical equation, and that the height of the 0 tower would go in another place, and we'd simply have an equation if we just built it out of y equals blank times x plus blank. Well, we take that rate of change, instead of m, we put it into the equation, 2. And then we take that height from our 0 tower and we put it into the equation, 1. And we see that this pattern has actually got an equation that goes along with it, a very unique equation, and it tells us that we can find the height of any tower, y, given the tower number, x. Well, simply to translate this into a graph, that 0 tower is when x equals 0. And we can plot a point at 0, 1. 0 and 1 high. Then we can plot another point at 1, 3. Tower number 1 is 3 high. 2, 5. Any guesses on what this one would be? Absolutely. And we could go on and do this over and over. If we were to plot these points and draw a line through them, this is the graph of y equals 2x plus 1. Now, any pattern works that way. Take a look at the next pattern. This was another one that we did in class together. And we have tower number 1, 2, 3, and 4, and we see that we have tower 1 is 1 high, and 2 is 4 high, 3 is 7 high, and 4 is 10 high. And we could find that 5, and we did this in class, is 13 high, because what we've identified is that each time we go over 1, we're going up 3. And we find that we have this common rate of change that we can put into our magical equation, y equals something times x plus something. Well, there's where we put that 3. It's the one that's multiplying times the x. And then we have to find the height of our 0 tower. But oh, look. If this is the bottom, we want to put our 0 tower here, if this is the bottom, our zero tower is going to be somehow underground. And if these are going up by 3 each time, our zero tower is actually going to be 1 minus 3, which we would call negative 2. You see how we went backwards here, so we took 3 off? Well, we go backwards here and we take 3 off. So we find the height of our zero tower is actually negative 2. So here we get this equation, y equals 3x minus 2. And again, it's just a graph. If we were to graph this, we would come over to this y-axis, that's where x is 0. We would put a point at 0, comma, negative 2. Another one at 1, comma, 1, 2, comma, 4, 3, comma, 7, 4, comma, 10. We could go 5, comma, 3. See, because every time we go over 1, we're going up 3. Over 1, up 3. Over 1, up 3. Over 1, up 3. It's kind of like a stairway. And we find that we can also graph this line, and I'll get out of the way momentarily. And we would have the graph of this line. And this is just the way these towers relate to the slope-intercept form of an equation, y equals mx plus b. You'll notice we have the same point on both lines. This is called a point of intersection, and in the later lessons we're going to study that in a little bit of detail. So thank you, and I hope this helped.